Good morning, students. Today I am going to take up applications of differential equations. Applications of differential equations. I have already sent you notes of these differential applications. Okay, you have to go through those notes. I'll be explaining a few examples and then you have to proceed yourself. Now, let me begin with Krikov's law. Or some may pronounce it as Krichov's law. What it does say is that if you have inductance, capacitor, inductor, a capacitor, a resistor, and electromotive force. Inductance in Henry's, capacitance in inductance in Henry's, yes, capacitance in ohms, resistance in farads, and E is the electromotive force in volts. If you have these three, LCR circuit, we say it as LCR circuit, then as per Krikov, L di by dt plus q by c plus Ri is equal to E. This is the differential equation given by Krikov. If you have an LCR circuit, LCR means you have an inductor, a resistor, a capacitor, and an inductor, electromotive force E. Then this is known as LCR circuit. LCR circuit. So for LCR circuit, we have this differential equation given by Krikov. So let me take up first example. See, let me take up the first example. Example is like this. If inductor of 2 Henries, this is an inductor of 2 Henries, a resistor of 16 ohms, resistor of 16 ohms, a capacitor of 0.02 farads is connected with an electromotive force E. If an inductor of 2 Henries, a resistor of 16 ohms, a capacitor of 0.02 farads are connected with an electromotive force E, then, and if the current, let me tell you, what is this Q? Q is the charge and I is the current, means dQ by dt. If at t equal to 0, the current, the charge on the capacitor and current in the circuit are 0. If in this circuit at initial stage, the charge on the capacitor, means charge on the capacitor at initial stage 0 is equal to 0. If charge on the capacitor is equal to 0 at t equal to 0 and current in the circuit, means I0 is equal to 0, or we can say Q dash 0 is equal to 0. Then we have to find charge and current at some time t greater than 0. Fine? Let me again explain you. If inductor of 2 Henries, a resistor of 16 ohms, and a capacitor of 0.02 farads are connected with an electromotive force E. Okay? Then, and furthermore, if charge on the capacitor and current in the circuit are 0 at equal to 0, we have to find charge on the capacitor and current into 0 at some time t greater than 0. Let me suppose that at first A, my electromotive force is 150 volts. Okay. So this is the question. Now, as per Krikov's law, this is an LCR circuit. So I have to use all the three, L, C, and R, and E. Everything is given. L is given, Q is given, R is given, E is given. So by Krikov's law, by Krikov's law, L 2 Henries di by dt plus Q by C. So your C is 0.02 farads, 0.02 plus R resistance is 16 ohms. 16 I is equal to case 1 E is 150 volts. Okay, I have this differential equation. If a if an inductor of 2 henries L is the inductance, is connected with a capacitor of resistor of 16 ohms and a capacitor of 0.02 farads, Lcr circuit, with an electromotive force 150, I have by Krikhov's law, this is the differential equation. Now, you know Q is the charge and I is what? dQ by dt. Since this is 2H, what is I? dQ by dt. So this is d2q dt square plus Q 0.02 farads. It is 2 by 10, 2 by 100 plus 16. Your I is dQ by dt is 150. Okay, I have replaced I. Your I is dQ by dt, so I have replaced I here dQ by dt and I here dQ by dt. Or this is 2H. Henries. H is Henries 2. 2 d2q dt2 plus 50 q plus 16 dq by dt is equal to 150. Or this is d2q dt square plus 8 dq by dt plus 25q is equal to 150/75. Okay, this is it. This is the differential equation, or this differential equation can be written in this form: d square plus AD plus 25 operating on Q is equal to 75. This is a differential equation. This is a linear differential equation with constant coefficients. You can always solve it. This is very easy. This is FD operating on Y equal function of X. So this is FD. Instead of Y you have Q. So you will find Q instead of Y. So auxiliary equation is m square plus 8m plus 25 equal to 0. So what's m? Minus b square minus 4ac by 2a. So minus 8 plus minus under root of 36, which is 6 by 2a. So under root of 36, it is 6 iota. So this is m is minus 4 plus minus 3i. So complementary function is what? A raised power minus 4t, because your q is function of t. C1 cos 3t, C2 sin 3t. And you can find particular integral also. It is 75 by FD, d square plus AD plus 25. You have only 75, so you can write e raised power 0t. So you have to replace d by 0. This is 75 by 25 which is 3. So your Q is complementary function plus particular integral. So Q is e to the power minus 4t c1 cos 3t c2 sin 3t. Okay. Plus particular integral, which is plus 3. You can always find dq by dt. Do it. So this is charge on the capacitor and current in the circuit at some point t which is greater than 0. You can always use the initial conditions. There were two initial conditions. Initially charge on the capacitor is 0 and current in the circuit is 0. You can always use Q0 is equal to 0 and Q dash 0 equal to 0 to find this C1 and C2. Okay, let me show this. So I will show for the current Q only. You can always find dq by dt likewise. Okay, you see it is given that Q0 is 0. Now Q0 equal to 0 means C1 cos 0, C2 sin 0 is 0. You will get C1. I don't need to show this because this is quite easy. You see, when Q is t is 0, you will get e raised power 0, which is 1, C1 cos 0, which is C1 plus C2. You will get C1 equal to 0. For derivative, you will get C2 equal something else, and you will do it. You will do it yourself. Okay. Now, let me take up this question only. And electromotive force E is equal. This is B section of this question. 300 sine, say 3t. E equal 300 sine 3t. So by Krikov's law, L di by dt plus Q by C plus Ri is equal to E, means L 2 Henries. This is C 0.02, which was 50 Q, and this is 16 I is dq by dt equal 300 sine 3t. Okay, this is part B of the same question. You have an inductor of 2 Henries connected with a capacitor of 16 ohms, inductor of resistor of 16 ohms and capacitance of 0.02 fards, connected with an electromotive force 300 sine 3t. Earlier it was, I had taken 150. Now this is 300 sine 3t volts. So by this you will get twice d square, or d square only. You can take d square outside. D square plus 8d plus 25 operating on Q, 150 sine 3t. So this is another question. This is a linear differential equation with constant coefficients. You have to find complementary function. For sine, you know you have to replace d square by minus a square. You will always find particular integral. So Q will be CF plus PI. Q is same because you have the same differential equation on the left hand side. So Q is same. This is complementary function is same. Particular integral will be different because you know particular integral for different functions is different. I have already given you the solution also, but the solution which I have forwarded to you is because of Laplace transform. You don't know Laplace transform, but you need to know the question. What is the question and how we are solving it by using the usual methods. Usual methods means which I have already shown to you. Linear differential equation with constant coefficient or variable coefficient or whatever. So this is the question, you can always find it. Okay, I have forwarded few more questions for your practice only. Now let me take up one more question. See, let me use Newton's law now. See, this distance is x. See, the question is a particle P of mass 2 m grams. Mass कितना है? Mass is 2 mg. A particle P of mass 2 mg moves on x-axis. This is x-axis, okay? This is x-axis. This is the origin, O. Moves on x-axis and is attracted towards the origin. Particle P is attracted towards the origin with a force numerically equal to 8x. With a force numerically equal to 8x. Since this is, when x is positive, this force is acting backwards. So what will be the force? Net force will be minus 8x, not plus 8x. See, x is positive. This is attracted towards the origin, backwards. Okay. So net force will be minus 8x. If it is negative, if x is negative, then this will be attracted towards the origin. Okay. This will be again minus 4x. Minus 8x. Net force will be again minus 6. X is negative and this is going towards the positive thing. So this will again be, whether x is positive or x is negative, net force will be minus 8x. Okay. So the question is, if a particle P of mass 2 mg moves on the x-axis with a force numerically equal to 8x and is attracted towards the origin. If initially at rest x is equal to 10 mg, 10. Okay. If at rest x is equal, if it is initially at rest, let me suppose that this is initially at rest at x equal, this particle is initially at rest at x equal 10, means x0 is equal 10. We have to find position of the particle at any time, okay, t greater than 0. Okay, yes. If a particle P, this is the particle P, this is here, this is attracted towards the origin with a force numerically equal 8x. But at t equal to 0, means at initially it is at rest. Initially it is at rest at x equal 10. This is given, means x0 is equal to 10. You have to find this x at some subsequent time t. See, okay. You know, we have the formula, Newton's formula. What is that? Mass into acceleration is equal to net force. Mass into acceleration is equal to net force. This is the formula, you know. You have now here, let me again put up the question. A particle P of mass 2 mg is moving on x-axis. Okay, this is moves on x-axis and is attracted towards the origin. So I have said that net force will be minus 8x. Okay, initially it is at rest at x equal 10, means x0 is equal to 10. You have to find x at subsequent time t greater than 0. I have used the formula, Newton's formula, mass into acceleration is equal to net force. This is very easy. Mass is 2 mg. This is d square x equal net force. Net force is minus 8x. Okay, fine. Or you have twice, you can, this is d square plus 4 operating on x equals 0. Very simple question. D square plus 4 operating on x. So what is the, you have to find this x now. Okay, you can put small x also, doesn't matter. So your auxiliary equation is m square plus 4 equals 0. So what's m? Plus minus 2 iota. What is the complementary function? Which is x in this case because right hand side is 0. this is C1 cos 2t, C2 sin 2t. Fine. This you have got. This is all you are supposed to find. If you want to find the particular solution, then you can use this x0 equal 10. You will get the solution. Fine. Otherwise, this is a solution. This is the general solution. For particular solution, you have to use x0 equal 10 and you will get it. Now, let me proceed further in this problem only. Now, for case B, you see, for this, no other force act. Okay, you have mass into acceleration is equal net force. Now, let me suppose that there is a damping force. There is one more force acting on this side. What is that force? It is 8 times the instantaneous velocity. Let me suppose that a damping force of 8 times instantaneous velocity acts on this particle. Means this is not just 8x, force is not just 8x, this is damping force is something else. It is 8 times instantaneous velocity. Instantaneous velocity means dx by dt. एक तो 8x x कटता है और मैं कह रहा हूं एक और फोर्स है डैम्पिंग फोर्स which is 8 times dx by dt instantaneous velocity. Now what will be the net force? Since these are, see, this is attracting towards the origin. Again, this force will be negative, this force will be negative, and total force will be this plus this. Net force will be this one. फिर से सुन लीजिएगा. पहले क्या था? A particle P of mass 2 mg was moving on the x-axis with a force numerically equal to 8x and is attracted towards the origin. That's why force was negative. Now we say this is not the only force which is acting on this. There is one more force acting on this particle which is 8 times dx by dt instantaneous velocity. This will always be negative because again this is not moving in this direction. This is attracted towards the origin. So net force will be this. So by Newton's law, what will be the differential equation? Differential equation will be mass into acceleration is equal net force minus 8x minus 8 dx by dt, because net force is this one. Or you have two dx by dt plus 4 dx by dt plus 4x is equal to 0. Okay, this is the differential equation. You have got one more differential equation, which is a linear differential equation with constant coefficients. Now, for this you have d square plus 4d plus 4 operating on x is equal to 0. Its auxiliary equation is m square plus 4m plus 4 equals 0, or m plus 2 operating on nothing. M plus 2 whole square is equal to 0. So m is equal to minus 2 and minus 2. So what will be the complementary function? Because complementary function will be the solution, right hand side is 0, it will be c1 plus c2t e raised power minus 2t. This is it. This is the solution. Okay. Linear differential equation with constant coefficient. Whether you have used this, there is one more, bending on beams. I have forwarded notes to you. You can check it, you can solve it. I have given the solution. Solution depends on Laplace transform. You have not done Laplace transform, so you will try to solve it by using these methods which I have already shown to you. Okay, if you have any problem, you can contact me through my number, or we can have one interactive session later. Okay, thank you very much.